Good morning, students. This is lesson number 2, Work and Energy of class ninth. Generally, any mental or physical activity is referred to as work. When we walk or run, the energy in our body is used to do the necessary work. We say that a girl who is studying is working or performing work, but that is mental work. In physics, we deal with physical work. Work has a special meaning in physics. So, the definition of work is said to be done when a force applied on an object causes displacement of the object. So, formula of work is equal to force into displacement. Next point is work done changes in the direction of displacements. See the diagram. The force F is applied in the direction of the string, that is at an angle with the horizontal. Let theta be the angle that the string makes with horizontal. When we can determine the component F1 of this force F, which acts in the horizontal direction by means of trigonometry. So, cos theta is equal to base upon hypotenuse, cos theta is equal to F1 upon F2, and thus the work done by F1 is equal to F S cos theta. So, our conclusion about the work done we can display in the boxes given below. Work done for specific values of theta in the following table. Number 1, theta 0 degree when cos theta is 1, work done is equal to F into S. Our conclusion is it is positive work. Number 2, theta 90 degree cos theta is equal to 0, then work done is 0, means it is 0 work. And when theta is 180 degree cos theta is minus 1, when work done is equal to minus force into displacement, that is negative work. Unit of work is equal to force into displacement, then the unit of work is joule. 1 joule, if a force of 1 Newton displaces on an object through 1 meter in the direction of the force, the amount of work done on the object is 1 joule. 1 joule is equal to 1 Newton into 1 meter. Another unit in CGS system of work is 1 dyne, and the relationship between joule and erg is 1 joule is equal to 10 raised to 7 erg. Next point is positive, negative and zero work. In last table, we will study these definitions. Number 1, when the force and the displacement are in the same direction, theta is equal to 0 degree, the work done by the force is positive. When the force and the displacement are in opposite directions, theta is equal to 180 degree, the work done by the force is negative. And last, when the applied force does not cause any displacement, or when the force and the displacement are perpendicular to each other, theta is equal to 90 degree, the work done by the force is 0. The example of zero displacement or zero work done is, suppose an artificial satellite is moving around the earth in a circular orbit. As the gravitational force acting on the satellite along the radius of the circle and its displacement along the tangent to the circle are perpendicular to each other, the work done by gravitational force is 0. Institutes of at work. The National Physical Laboratory, New Delhi, was conceptualized in 1943. It functions under the Council of Scientific and Industrial Research. It conducts basic research in the various branches of physics and helps various industries and institutes engaged in developmental work. Its main objective is to establish national standards of various physical quantities. Then our term is energy. What is energy? All of you know that the capacity to do work is called as energy. Then the examples are, if a pot having a plant is kept in the dark, the plant languishes. Number 2, on increasing the volume of a music system or a TV beyond a limit, the vessels in the house start vibrating. Collecting sunlight on a paper with the help of a convex lens burns the paper. Means the capacity of a body to perform work is called its energy. The units of work and energy are the same. Thus, unit in SI system is joule, while that in CJ system is erg. Then types of energy. You'll already learn that energy exists in various forms like mechanical, heat, light, sound, electromagnetic, chemical, nuclear and solar. And we are going to study two forms of mechanical energy, namely potential energy and kinetic energy. Firstly, we will see kinetic energy. What is kinetic energy? The energy which an object has because of its motion is called its kinetic energy. The work done by a force to displace a stationary object through a distance is the kinetic energy gained by the object. So, kinetic energy is equal to work done on the object, means force into displacement. Examples of kinetic energy are, a fast cricket ball strikes the stumps. Number 2, the striker hits a coin on the carom board. Number 3, one marble strikes another in a game of marbles. Expression for kinetic energy. According to the Newton's second law of motion, kinetic energy is equal to half m into v square, means 1 by 2 into mass into velocity square. Now, potential energy. The energy stored in an object because of its specific state or position is called its potential energy. Examples of potential energy are, number 1, an arrow is released from a stretched bow. Number 2, water kept at a height flows through a pipe into the tap below. Number 3, a compressed spring is released. Expression for potential energy. To carry an object of mass m to a height h above the earth's surface, a force equal to mg has to be used against the direction of the gravitational force. The amounts of work done can be calculated as follows. Work is equal to force into displacement, W is equal to mg into h, therefore W is equal to mgh. The amount of potential energy stored in the object because of its displacement, potential energy equal to mgh. Another point is transformation of energy. Energy can be transformed from one type to another. For example, the exploding firecrackers convert the chemical energy stored in them into light, sound, and heat energy. Here, from this table, we can understood the forms of energy. Electrical energy, when converted into mechanical energy, example is engine or fan. When electrical energy is converted into light energy, example is electric lamp. When electrical energy is converted into chemical energy, example is secondary cell. When electrical energy converted into sound energy, example is loudspeaker. And when electrical energy converted into heat energy, example is heater. So, this electrical energy is converted into all the forms of energy. Again, mechanical energy is converted into electrical energy, example is generator. When light energy is converted into electrical energy, example is solar cell or photoelectrical cell. When chemical energy is converted into electrical energy, example is primary cell. When sound energy is converted into electrical energy, example is microphone. And when heat energy is converted into electrical energy, example is thermocouple. From this table, we can understood all the transformation of energy. Then our next point is law of conservation of energy. This law states that energy can neither be created nor destroyed, but it can be converted from one form into another form. Thus, the total amount of energy in the universe remains constant. From this diagram, we can study the following points. Tie the two pendulums to this horizontal thread in such a way that they will not hit each other while swinging. Now, swing one of the pendulums and observe. What do you see? You will see that as the speed of oscillation of the pendulum slowly decreases, the second pendulum, which was initially stationary, begins to swing. Thus, one pendulum transfers its energy to other. Next point is free fall. What is free fall? If we release an object from a height, it gets pulled towards the earth because of the gravitational force. An object falling solely under the influence of gravitational force is said to be in free fall or to be falling freely. Let us look at the kinetic energy and potential energies of an object of mass m falling freely from height h when the object is at different heights. As shown in the figure, the point A is at height h from the ground. Let the point B at a distance x vertically below A. Let the point C be on the ground directly below A and B. Let us calculate the energies of the object A, B and C. Number 1. When the object is stationary at A, its initial velocity u is equal to 0. Therefore, total kinetic energy is equal to mass into gravitation into height mgh. Number 2. Let the velocity of the object be vb when it reaches point B having fallen through a distance x. Then total energy is equal to again mass into gravitation into height mgh. Number 3. Let the velocity of the object be vc when it reaches the ground near point C. Then again kinetic energy is equal to mass into gravitation into height, that is total energy is equal to mass into gravitation into height. Thus, every object has potential energy when it is at a height above the ground, and it keeps getting converted to kinetic energy as the object falls towards the ground. On the reaching the ground at point C, all the potential energy gets converted to kinetic energy, but at any point during the fall, the total energy remains constant. That is, total energy is equal to potential energy plus kinetic energy. Total energy at A is equal to mgh plus 0 is equal to mgh. Total energy at B is equal to again mgx plus mgh minus x, that is equal to mgh, and again total energy at C is equal to 0 plus mgh, that is equal to mgh. Next point is power. Power is the rate at which work is done. Power is equal to work divided by time, that is equal to W divided by T. If W amount of work is done in time T, then P is equal to W divided by T. The unit of power in SI system is watt. 1 watt is equal to 1 joule upon 1 second. In the industrial sector, the unit used to measure power is called horsepower. 1 horsepower is equal to 746 watt. The unit of energy for commercial use is kilowatt hour. 1000 joule work performed in 1 second is 1 kilowatt power. So 1 kWh is equal to 1 kW into 1 hour. Then 1 kWh is equal to 33.6 into 10 raised to 6 joule. Electricity used for domestic purposes is measured in units of kilowatt hour. 1 kWh is equal to 1 unit. Then an introduction to a scientist. The steam engine was invented in 1781 by the Scottish scientist James Watt, 1736 to 1819. This invention brought about an industrial revolution. The unit of power is called watt in his honor. James Watt was the first scientist to use the term horsepower. In this way, our lesson is over. Thank you so much.
10 Newton and moved a book 30 centimeter in the direction of the force. How much was the work done by the Ravi? Suppose here is the book and directly he pushed the book or applied the force. How much that is work done we have to calculate here. So given data, force is equal to how much? 10 Newton. Yes, means displacement. That book is 30 centimeter and work done we have to calculate here. So formula is W is equal to F into S, means force into displacement. So write down here and put up the values. Force is how much? 10 Newton. Displacement is 0.3 meter. So directly multiply by here 10 into 0.3, that is equal to 3, and the unit of work done is 2. The work done by the running is 3 joule. The another problem. If a 1200 watt electric iron is used daily for 30 minutes, how much total electricity is consumed in the month of April? In the month of April, there will be 30 days. Okay. Then given data is power P is equal to 1200 watt. You know that 1000 watt is equal to 1 kilowatt. So 1200 into 10 raised to minus 3 kilowatt is there. Then time T is equal to 30 minutes. 30 minutes means 1 hour is equal to 60. Then 30 minutes means half, 0.5 hour. Then number of days. Number of days in the month of April is 30 days. So put the value here. Then to find electricity consumed, E. So formula is E is equal to P into T into number of days. P means 1200 into 10 raised to minus 3. Then time T is equal to what? 30 minutes means 0.5 hour and number of days is 30. So E is equal to 1200 into 10 raised to minus 3 into 50. Here 0.5 into 30 is equal to 50. Then 1200 into 15 is equal to 18,000. 18,000 into 10 raised to minus 3. Minus 3 means that is equal to what? 18,000 means put the dot is here, means 18 unit. So electricity consumed is equal to 18 unit. So our answer is total electricity consumed by electric iron is 18 unit. An electric pump has 2 kilowatt power. How much water will the pump lift every minute to a height of 10? In this problem, we will solve what is See here, what are the given? Given data, power. Power means P is equal to 2 kilowatt of that power. So 1000 watt is equal to 1 kilowatt. So 2 kilowatt is equal to 2 into 10 raised to 3 watt. Another they given time. Time T is equal to 1 minute. 1 minute means 60 seconds. Then they given the height, that is 10 meters. Then whatever we find that amount of water lifted by the pump, that is the mass of that water. So what is the formula? Formula is power is equal to W upon T. That is equal to W is equal to what? mgh, mass into gravitation into height divided by time. So calculation is power is equal to mgh divided by T. So we put the values here and find out the solution. P is equal to what? 2 into 10 raised to 3 watt. Then M we don't know. Then what is the value of this G? G means gravitation, that is 9.8, and H means height, whatever they given, 10 meter, divided by time, that is 60 seconds. So we here do the calculation. 2 into 10 raised to 3 is equal to M into 9.8 into 10 divided by 60. Then we don't know M, so M is going to another side, and all this calculation we do here. That is 2 into 10 raised to 3, this 60 directly goes to here into 60 divided by, that is going to denominator, 9.8 into 10. So what is do here? 2 divided by 10 is equal to 5, then 5 again divided by 60 is equal to what? 5 1 are 5, here is 1, 5 2 are 10. So 12 into 10 raised to 3 divided by this 9.8. Whenever we do the calculation, see here 1224.5 kilogram. This is the value of that mass of that water. So write down as answer the amount of water lifted by the pump